first one is 4, followed by 7, 4, 5, 3, 1.
And add up to, how many people agree with Tyler? 1, 2, 3, 4, several people. Okay, great. So I do too. Those are the numbers. That's how many of those pulse rates fall in each of the categories. Now, if I took that and I flipped over to the other side of the paper, when I've given you some graph paper, the top left, we could now draw, I put you a little bit, our frequency histogram, because we know what our boundaries are, and we know what our frequency is. And so let's draw our version of histogram. I'm sure mine will be kind of bad, but this broken kind of squiggly annotation means I'm not starting right at 0. And so I'm going to start my first boundary at, what did we say, 64.5. We go to 74.5. We go to 84.5. 94.5, 104.5, 114.5, and 124.5. Those are our boundaries, right? The lower and the upper boundaries of each one. And that's with frequency. How many we saw in each one? 2, 4, 6, 8. So our histogram should look, and this was pulse rate. Our histogram should be the first category, what did you say, Tyler, 4?
Yeah.
And the next one, I think you said, let's see, this is 2, 4, 6, 8, I think you said was 7, right? Next one was 4. Next one was back up to 5. The next one was down at 3. And the last one was 1. So that's the distribution of our data. That's how our data fell out in those intervals. And I could put the numbers here, 4, 7, 4, 5, 3, 1. And there's space, I think, on the upper left-hand back page for you to make a graph like that. That's called a frequency histogram. Now, you could make a different looking frequency histogram if we made more classes, I made less classes, but with our 6 classes, based on the spread of the data that we had, we got the width of 10, which was kind of nice, and that's what ours should look like. Make sense, everybody? And these are just techniques to try and figure out what the data looks like. And they're a little art and a little science, okay? But the procedure that we follow is actually how you want to make these things, or how you're going to create them. All right, let's go back to the, if you can go back to the first page, which is our table. We've got a lot of blank in the table here. So let's talk about filling up the table here. And we can then make some more charts over there. But anybody know what relative frequency is? What's relative frequency? Well, relative frequency is like, kind of like the pie chart. How much of the data falls into each of the categories? So how much of all of the data relatively falls into this category? 4 out of what? 24. So what I need now is the decimals to 3 decimal places for each of these categories. 4 out of 24, that one's pretty easy. That's 1/6, so that's 1.167. What are the other 5 categories? And what do they have to add up to, by the way?
1.
They got to add up to 1, right? Because that's the whole pie. They got to sum to 1. This must sum to 24. This has got to sum to 1. But what I need is these 5 decimal points. You got them, Tyler?
Well, question. I got 1.001.
That's because of rounding, right?
Right, yeah.
Yeah, okay.
I didn't know how many to round to.
So just give me the 3 decimal places for each of the categories, okay? Chelsea, you got it? Okay, good. Let's see if people agree with you. What's the second one?
0.292.
0.292. Go ahead.
0.167.
0.167.
0.208.
0.208.
0.125.
0.125.
And 0.042.
0.042. How many people agree? Okay, so that looks good. That's the relative frequency, right? That's how much, actually, it's a decimal point, but it could be a percentage if I multiply by 100. It's a slice of the pie that's accounted for by that particular category. And hopefully they add up to 1 or 1.001 or something based on rounding, but they should add to 1. All right, let's figure out the next